Welcome to video 2 of the bioplastic analysis series, where we'll be comparing the strain and stress characteristics of 3 different bioplastics that we made from our extrusion kit. To begin, we will be collecting the coordinates of the top mark that we made on the neck region of the bioplastic and of the bottom mark. By measuring the distance between these 2 points, as the bioplastic is stretched apart, we will be able to calculate strain. Furthermore, we will also be collecting data on the stress. You will do this using a Newton meter or a weight meter, depending on what you have available to you. If you have a Newton meter, you will enter your data in this column. If you have a weight meter, you will enter your data in this column. There are 3 sheets on the bioplastic analysis spreadsheet that you will use to enter data here, here, and here. And there is one final sheet that will be used for comparison, where you will make a final graph. As you can see, the width and height measurements have already been entered, taken from my lab notebook when I measured the neck region. You can fill in these cells with your own data from your own notebook that you took from measuring your bioplastics. We will begin first by looking at the experimental videos that we took from this experimental setup. From there, we will track the top coordinate and the bottom coordinate and enter the data points here. I'll open the instructions, open the University of Calgary's video analysis tool. We'll select Open Video, go down to your computer's media, and then select the video of the red bioplastic. Now, if you recall, the red bioplastic here was our control bioplastic. It was made from 1 gram of gelatin and 1 milliliter of glycerol, as well as 1 gram of starch. In the video analysis tool, we can collect X and Y coordinates, X meaning the horizontal plane and Y being the vertical plane. We can collect these coordinates synced to time as well. To begin, we'll watch one full playthrough of the video uninterrupted so that we can find the rough time points of where force is applied and a final time point of when the plastic breaks. Now we can note here my hand is reaching into the video and begins pulling down roughly at 4.9 seconds. We'll make a note too of when the plastic breaks, roughly 7.5. This way we don't need to watch the video from the beginning each time we're collecting data. So now I'll rewind the video to roughly 4.9. Roughly 4.9 here, because this is when I begin pulling down. So I will click on the video itself, which will allow me to zoom in, and then I can observe the top mark that I made on the bioplastic. What I'm going to do is I'm going to place my mouse on the top left corner of the mark. You can see to the right of the mouse there are 2 coordinates, and they correspond to the X and Y data points. Each time I click on the mouse, you can see that the time will move ahead by 1 frame. So I click once, and now we are above 4.9 seconds. I click again, and you can see we're at 4.925, and the time will continue to move forward each time I click. Now, I am going to be clicking in the top left point of the black mark, and as you can see, as I'm clicking, it is slowly moving, so I need to make sure that my mouse is also moving following that black mark. Although it can be kind of hard to see sometimes, do your best to keep the mouse accurately over that black mark. And we will keep doing this until the bioplastic itself breaks, which was at roughly 7.5. We can see the bioplastic here starting to rip, and I'm clicking, and at this point 7.508 the bioplastic has broken. So I can see here that the U of C's video analysis program has collected data starting from the first time point where I started clicking all the way to the final time point. What I'm going to do is click Export Table. I'm going to go to my downloads, and then I'm going to copy the entire table. And what we'll do is we are going to paste these values. Now that I don't need this, I'll close the screen. We're going to paste these values into our bioplastic analysis spreadsheet. So this was for the red control bioplastic, the top coordinate. So I would click on the top point underneath time, and then I will paste my values into the program. Now, as you can see, all these cells are now filled, and as well, cells here have been filled as well. So now we'll collect the data for the bottom coordinate. So we'll go back. I'm going to close this window and open up the link one more time. Select Open Video, and now because I'm collecting the bottom coordinate, this is on the same video. So I'm going to again choose that same video with the red bioplastic. And now this is a very important part. The first time point we chose needs to match the time point for the bottom coordinate. So what we're going to do is we're going to skip ahead to the frame corresponding to 4.891 seconds. So I'm going to start moving up to 4.981. I believe it is 4.891. Should be. There we go. So you'll just need to click around a little bit, maybe click play, or you can always just start clicking, which will move it ahead by one frame. And I'll just delete those few rows. So let's see, 4.841, and then I'll move ahead by one frame, 2 frames, 3 frames. Now I'm at 4.891, and I'll delete those last rows because I don't need them. So now, again, to remind ourselves, we are collecting the bottom coordinates of that black mark on the neck. So I'll zoom up on the bottom, and we can see there is a slight black mark right here. I could have done a better job of making these marks, so keep that in mind. I'm again going to put my mouse on the top left-hand corner of the mark, and I'm going to begin clicking. Again, I'm going to follow that black mark as much as I can. I can see the plastic itself is starting to twist, which is why it's very important to make sure that black mark finds its way all around the dumbbell bioplastic. I'm going to continue clicking, and we can see the plastic is beginning to stretch here. Now, if you were to just keep your mouse in the same position and continue to click, the data would not be very usable because it wouldn't actually be tracking this black mark. You can see that this black mark has moved down from roughly about here down to here, and actually I clicked on that last point, so I'm just going to remove that last row. Anytime you click somewhere that you don't mean to click, you can always just remove that last row, that last data point. Okay, so now I can see my black mark, and the plastic has broken. So what I'm going to do, same thing as the top coordinate. I'm going to export the table, go to my computer's downloads. The table will be opened. I'm going to copy the entire data set, and now I can delete that because I have it saved. And I'm going to return to the bioplastic analysis spreadsheet, click on the time point under for bottom coordinate, and paste those values in. Now, you can see here I have one less data point for the bottom than the top. That just means for the top I clicked one extra frame. So to make our lives easier, we can just delete that last frame to make all of our data even. Okay, so now we can see that the data for strain has been filled in because of the auto formulas that are already present in the spreadsheet. This data shows us how much the material stretched. So a very low value would indicate that there was not a lot of stretch, and the higher the value goes, the more it has stretched. Now we need to collect our data for stress. So in my case, I was analyzing my video with a Newton meter. I'll again open the U of C's link instead of a weight meter, which will only change which column I enter the data in. So for this column, we are concerned with the numbers on the scale itself. So I will move up to 4.891, where we began recording. And then perfect. Zoom out. Now, on the Newton meter, you can see the N, which stands for newtons. This yellow mark shows how many newtons of force are being applied. So initially, we can see that we are at 1, 2, 3 newtons. So at 4.891, which is our time here, I am going to plug in 3 newtons. Next, I'm going to skip ahead on the video until this marker is at 5 newtons, at which point I will record the time. I will note the time, find that time point, and then record the newtons which it corresponds to. So that will look like this. I have the Newton meter in frame here. I begin to click, and we can see the measuring apparatus begins to rise. At this point, we've hit 5 newtons, so we are at time point 5.075. So I will go down to 5.075, which is here, and I will type in 5 newtons. Now you may be wondering, well, Tim, there is a large gap between the data point 3 and the data point 5. Do not be concerned. In the next column here, force, we'll be using a formula which will fill in these data points. So now, continuing on, we will look for 7 when it has reached 7 or 8 newtons. The reason I say 7 or 8 is because the hatch marks along the scale are not always visible. So if it's extremely blurry and it looks like it might be 7 newtons, you can continue on to 8 newtons to get a more accurate measurement. So we're moving up, and you can see here the marker is roughly at 7, but it's very blurry. So I'm going to keep moving one more frame, and now we can see it's clearly at 7. So at 5.241 seconds, 5.241, we will be at 7 newtons. I'll continue clicking. Here we are at 10 newtons, so at 5.541. 5.541, we're at 10 newtons. Whoop. 5.541, yes, 10 newtons. Continue on. I'm going to go back just a little bit, just ahead of 5.41. And at this point, we can see that the Newton meter is in line with the 12 with the 12. So at 5.708, 5.708, we are at 12 newtons. Continuing on. At this point, we are at 15 newtons. So at 6.041, I look down the time zone, 6.041, we are at 15 newtons. Continuing on, here I'm just clicking pretty quickly as I'm going through this. And I'm using the outside edge to line up my hash marks here. So at this point, we can see that the outside hash mark is in line with the 17 mark. Here is 15, this larger one, 16, 17. So it's 6.541. 6.541. We are at 17 newtons. Continuing on. And at this point, it looks like we're at exactly 20 newtons, which would be, oh, I went ahead by one. I just clicked one extra by accident. So there we are at 7.125. We are at 20 newtons. 7.125. 20 newtons. Whoa. There we go. Not 210 newtons. That would be a very impressive bioplastic. And what's our final time point? 7.491. So now you can see our final time point is 7.491, and here I am at 7.408. Because the Newton meter can be slightly blurry sometimes, any Newton value within the final 5 frames you can take as your final data point. So if you have a Newton value at about 21 and you know it's at 7.408 seconds, but it's too blurry to see exactly what the Newton meter records at this final point, these last 5 data points can all be summed together. So now I'm just looking for a data point that I can see. That last point, 491. This is our last data point. So I will go back 5 just to find the most clearest image. Here we go. So at this data point, this long mark is the 20, 21, 22. So at 7.375, 22. We'll continue on. At this point, we can see it's gone up 1 Newton. So here's 25, 24, 23. So that's 7.458. We're at 23. 7.458 would be 23 here. But to complete our data set, because it's within the last 5, I'm going to bring 23 down just to the bottom, just so that we have a final value in our data set. Now, as promised, I told you that we would fill in these data points in between because right now they're very empty. That's why our stress values are all 0. To do this, you're going to click in the force column, you're going to click equals, and then LIN FILL, lin fill. Now this is a function which will divide the difference between the 2 data points and fill them in increasingly. So as you can see, I'm going to select this data point and the next data point. Then I'll simply click enter. This data that loads, you can see the first value is identical, and then the difference between 5 and 3, which is 2, is then added in incrementally. Now the last data point you'll actually have to drag over to this side. If you were using a weight meter, for example, so let me just get rid of these values here, and we'll pretend like we had gotten our values from a weight meter. So say the weight was 0.2 kilograms, and then the weight was let's say 4 kilograms, roughly going up like this. You'll do somewhat of the same. So you will click equals lin fill from here to here. And then for the final data point, as you can see, the data point wasn't added in here when we were doing the weight meter, or here when we were doing the Newton meter. You're simply just going to drag that value in. Same thing on this side, drag that value in. Awesome. Okay, but since we weren't using kilograms, I'll delete these because we don't need them. We won't use those. We were using a Newton meter, so I'll continue in that fashion. And once you've done this, the first round, it gets a lot easier. Oops. So equals lin fill, top to bottom. I'm sorry, you don't actually have to drag this value in. Only for the very final data point will we have to do that. Here to here. And if you're new to using Excel, or in this case Google Spreadsheets, it's a really great program because you can type out a formula with variables in it, and then, whoa, clicked on something wrong there. Let's bring that back into focus. Yeah, the great part about this is you can fill in the cells with data points, so they're already preset with formulas. So if you are also trying to do your own experiment, Excel or Google Spreadsheets is a great tool to use. Almost to the bottom of our data set now, and here you can see that now all the Newton values are being filled in corresponding to the time points. And like I said, for the very last one, we will pull it over in that final spot. And there we have it. We have all of our data to calculate strain and stress for a red control bioplastic. We will repeat the same process for the high glycerol blue and high gelatin yellow bioplastics. So, as you can see, I have already filled in my width and height measurements that I had recorded in my notebook. And again, I will record that bottom coordinate first. So I'll open the instructions, go to my media, and I will open my high glycerol bioplastic video. Now, as you can see, I ran out of blue food coloring for this video, but I can assure you that this was the high glycerol sample. I just used green instead of blue. So, actually, first things first, we'll just watch a full playthrough, and we'll take a note of roughly when force starts to be applied and when the final point breaks. So it looks like there at 2.7 seconds, a force was applied, big stretch, and then just after 4 seconds, it broke. Okay. Oh, it was roughly at 2.7 when we started recording. Make sure my table is empty and ready to have data entered into it. Here's the black mark we can see, and I will click on the top of it. Again, it's moving to the left. I follow it to the left. It moves to the right. Follow it to the right. Slowly moving down. I start moving my mouse down. keep following that black mark until the plastic breaks. I might move it. Oh, there we go. And I clicked 2 extra times after it broke. Awesome. So now I will export the table just like before. Collect all this data. Copy that. We will now put that in the spreadsheet. And we can see our first time point is 2.658 seconds. So I am going to restart this. My green bioplastic. Okay, and then that first time point was 2.658. There we go. Perfect. Remove that final time point. All right, now for the bottom coordinate, we can see it's right there. So again, top left corner, and make sure you're following it. Now you can see it's twisting, which is why it's important to make sure that black mark goes all around. You can see the second black mark on the other side. That makes it a little easier to track. You definitely don't want to be clicking on a position other than that black point, because again, we are trying to measure the distance between the top and bottom black point. And at that point it is broken. Select export table. Copy these values in. I'll get rid of a few extra tabs there. And the time point, add that in. I need to make sure these time points match. They do. Make sure these last time points match. They do. Perfect. So now, next what I need to do is collect the data from the Newton meter, or if you have a weight meter, that as well. So I think what I'll do, can I just delete all these? Oh no, that will take forever. I will just reopen the program. .658 is the starting point. 2.6, one more, 58. There's our starting point. Our table is empty. And I'm going to zoom up on the bottom. So we can see here's the 0, 1, 2. That first mark is in line with 2 newtons. So I will put 2 right there as our starting point. And I will begin clicking. Very blurry, sort of hard to see. I might even go back a few frames. Here we go. So we can see the mark here for newtons. We'll start at 5, 4, 3. So at 3 seconds, 3.008. We are at 3. Perfect. Continue to click. It's going to zoom out. Zoom in a little lower. Oh, it's very hard to see which point it's at. Although here, if I'm looking at the outside, I can see the line is here in line with this first mark after the long mark. So anytime there's a long mark, it's a multiple of 5. So you have 0 here, then we have 5 here. So we know that that next mark is 6. So at 3.508, 3.508, we're going to be at 6 newtons. Continuing on. And with this video especially, I'm just looking for any point in the frame that I can distinguish which mark it's at. Oh, we are coming into focus. Alright, I need to go, what is the final time point? 3.892. That's the final time point, and I definitely can't see exactly where it is. Somewhere between 10 and 5 right here, but I can't quite see. So I'll go back one frame. This is a little bit clear, so I can count back from 10. Here's the black mark. 10, 9, 8, 7. So here we go. At 7 newtons, we're at 3.875 seconds. 0.875, and that would be 7, although because it's within the last 5, I'm just going to pull it down to that very last time point. So we have a complete data set. Now in the same way as with the red biocontrol, put lin fill into the force column, select the top and bottom data points, and then click enter. Click on the cell that's empty, equals, so I push the equal sign, then lin fill, and one more time. And finally, I'll just drag this value over like that. Perfect. Now, we'll do the same for the final yellow bioplastic. Our final yellow high gelatin bioplastic. In the same way as we've been doing, we will open the UVC's Calgary link, open the video analysis tool. Now I'll select the yellow bioplastic. And we will be recording the top coordinate here. So I'll watch one full playthrough. So it looks like roughly 3.5, 3.6 is when force was applied. You can see the Newton meter going up right here, and there it snapped at about 5.7. So what did I say? 4.5 was roughly? No, 3.5. Yes, we'll go just after 3.5, because I'm watching when my hand starts to move down. That's how I'm determining when I begin pulling. Okay, so this point, going to zoom up on that top, pick the top left portion of the mark, and I will just continue to click on it and follow it as it moves. At this point, I'll speed up the video until the plastic breaks. Perfect, I'll export this table. I think the video might have cut out there, but I exported the table back onto the Google Docs Bioplastics spreadsheet, and now I'm opening up the video for the yellow bioplastic again, and now we will take the bottom coordinate on this trial run. So again, I will zoom up to our start time of 3.675, and I'll click on that top left-hand corner of the black mark. Again, we want to stay as consistent as possible when we're clicking and collecting these data points. So remember to move your mouse as you click. And now our bioplastic is broken. So again, just like we did for the red control and high glycerol blue bioplastic, we'll export the table. And I'll paste them in here. Next, we are going to collect the data for the Newton from the Newton meter again. All right, so I'm going to move up to 3.675, zoom up on the Newton meter. I will record the initial newtons, which were 6. Oh, no, I'm wrong. It was not 6. I think it was closer to 11. The second time point, though, is at 15. Yes, there we go. The first time point, or first Newton point at the start time was 11, and at 15 newtons we're at 3.825 seconds. Now, as you can probably already tell, the Newton meter is going up by quite a bit, so I am recording the newtons at every 5 newtons. There we go, 30. And I'll keep clicking until I get to that 35, 4.991 seconds, so I'll scroll down. And I'll type in 35. There we go, 4.991. All right, for 40, we're at 5.391. And as you can see, this is within the last 5 time points. I'll delete these bottom 2 so our data is all the same. And because it was within the last 5 time frames, I will pull it down. And now we can carry on with our lin fill function and fill out the rest of this data table. Remember, if you are using a weight scale instead of a Newton meter, you'll just plug in your data under where it says weight in kilograms, and then to the left of that column where all those zeros are, they will be converted to the proper Newton unit corresponding to the kilograms. And there we have it. We have our final data set. So we collected data for our red, our blue, and our yellow dumbbell bioplastics. Thank you, everyone, and please join the next video with Max.